All right, Algebra 1 students, I appreciate you coming back in for lesson number 2 today. Lesson number 2 is going to focus on solving equations, listed right here. Should be some information that looks familiar to you. Solving equations is something that you guys should have spent some time doing at some point from 6th grade to 8th grade. It's a heavy emphasis of middle school math, and we build off of it big time in Algebra 1 and beyond. So just want to kind of get you guys fresh on solving equations again so that we can build off of it and add some new skills to your repertoire of what you already have. So diving right in, it says the goal of solving equations is to get the equation to look like this. Variable equals number. Or you can even say number equals variable. And what I mean by that is something as simple as like x equals 6 or w equals 9. Or like I said, number equals variable. It could be 13.2 equals h, right? Just some kind of number equaling some kind of variable. Did we find out what the value of that variable was? It says once we have done this, the variable equals the number. So whatever your number is the solution to that equation. This should look familiar from previous years and even our previous lesson, right? We were checking solutions in our previous lesson. Today is going to be more of an emphasis on solving the equation itself to find the solution. We have stated here, it says we have a clearly defined process for solving equations. That process is defined below. Your teachers in the past may have given you some steps. Essentially, even if they have been 2 steps, 3 steps, 5 steps, whatever, it's just this general process of solving equations to get the variable to equal a number. I just have them broken up into 4. Step number 1 is to simplify each side of the equation. So just use order of operations on the left, use order of operations on the right. 2, it says to use add subtract property to get rid of variables on one side. 3, use multiply and divide property to get the equation to say variable equals number. 4 is to check. So we're going to do all of those here. On these first couple of examples there. So looking at example A here on the left, we're going to go ahead and do that. So we have x minus 7 equals 11. We're trying to figure out what is x. What number minus 7 is 11? You can probably figure out in your head. You're probably thinking a number minus 7 that equals 11, 18. So we should end up with 18. This is a very basic example. We do this by the inverse. I'm not sure why that appeared there. So the inverse of subtracting 7 is adding 7 on the left. I have to add 7 on the right. What I do to one side, I have to do to the other. I keep it balanced. I keep it fair. Negative 7 and positive 7 cancel out. The goal is to get rid of that. I have, and I get x equals 18. And again, how do I check that, right? We're saying x, the solution to this is x equals 18. If I want to check it, I take the original equation right here, okay, and I plug 18 in for x and find out if that's true. So I have 18 minus 7 equals 11. I need to simplify the left. 18 minus 7 is 11. I get 11 equals 11. Is that true? It is true. So we must have found the one true solution, okay? And we have that there. All right, so a more complex situation we're going to hop in because this is something you should have some familiarity with, or more than some. You should have plenty. This is our first example on these notes where there's a variable on the left and the right. We see negative y. There's not a we don't see a coefficient in front. That's negative 1y then. Minus 6 equals negative 2y plus 1, right? So there's nothing I can simplify on the left because y and 6 are not like terms, right? One's a constant, one's a variable. And there's nothing that I can simplify on the right because negative 2y and 1 are also not like terms. So I can't actually add those. It says to add them, but I can't. They're not like terms. So I need to start moving variables onto one side of the equation. I have negative 1y here, and I have negative 2y on the right. Well, I'm just going to do the inverse of this negative 2y because I like to move the smaller number. So negative 2 is smaller than negative 1. So I'm going to add 2y here, and I'm going to add 2y here. Well, negative 2y and positive 2y create 0, which I don't need to write. They're gone. I'm going to do some math here then. I'm going to do this row. Negative 1 plus 2 is just 1y. I'm going to bring down my other terms I haven't touched yet. Minus 6 equals 1. Now this looks very similar to what we had over here, right? A variable minus a number equals a number, right? So I just need to get rid of this minus 6 or negative 6 by the inverse. The inverse of subtraction is addition. I'm going to add 6 here. I'm going to add 6 here. The goal is to get rid of that, right? Negative 6 and 6 make 0. 1 plus 6 is 7. So now I get y equals 7. I have found my solution. That's one of the biggest things we do in algebra. Now, check my solution. I'm going to go ahead and plug in 7 every time I see a y up above. I'm going to go ahead and do that in red. So I have negative, because there's a negative sign up there, negative 7 minus 6 equals negative 2. I'm plugging a 7 back in there, plus 1. I'm going to do some math. Negative 7 minus 6 is negative 13. Equals negative 2 times 7 is negative 14 plus 1. So now the left side is simplified. The right side is not yet. I'm going to have negative 13 on the left still equals negative 14 plus 1 is negative 13. I get a true statement, meaning the solution that I found is correct. Easy peasy lemon squeezy. Let's hop into example C over here on the right. Again, I see some stuff I need to be simplifying on both sides of this equation. I have 5 parentheses x plus 2, so I have 5 groups of x plus 2 equals, and I have 4 groups of x plus 1. We have the distributive property happening here. So let's go ahead and do it. 5 times x is 5x. 5 times 2 is 10, and it's positive because it's a positive times a positive. Over on the right, 4 times x is 4x. 4 times 1 is 4. We're just doing that same property there. So we get this. Again, we notice we have variables on the left and the right. I have 5x on the left. I have 4x on the right. You can move either one by doing the inverse. My suggestion is move the smaller one, right? So I want you to move this 4 because 4 is smaller than 5. So the opposite of a positive 4x, I'm going to minus 4x. I'm going to minus 4x. I know that these are gone. 5x minus 4x is just x. So I have x plus 10 equals 4. The opposite of a positive 10 is a negative 10, or the opposite of plus is minus. So I'm going to minus 10 there and minus 10 there. I have to treat both sides equally to keep it balanced. 10 minus 10 is 0, so I'm left with x equals 4 minus 10 is negative 6. Okay, again, to check it here in red, every time there's an x up above, I'm going to plug now a negative 6 in. So I get 5 parentheses. Negative 6 plus 2. This is me just checking to see if I got the first part right. The first part's what important. I'm checking to see, did I in fact do that correctly? Plus 1. All right, so order of operations tells me I need to do the parentheses first. Negative 6 plus 2 here would be negative 4 with the 5 on the outside multiplying. And over on the right side, I have negative 6 plus 1 is negative 5. 5 times negative 4 is negative 20 equals 4 times negative 5 is negative 20. I get negative 20 equals negative 20. That is true, so this must be correct. Good deal. Moving on to some examples that involve some just different starting looks. We just want to make sure we're comfortable with everything here. So this one on the left, we have 3a equals 18. That means it's saying 3 times a equals 18. We're trying to think of 3 times what number is 18, right? So we do the inverse. The inverse of multiplication is division. Divide by 3, divide by 3. 3 divided by 3 is 1. So I'm left with 1a equals 18 divided by 3 is 6. So I get a equals 6. If I want to check that solution, I'm going to do it here in red. I'm going to have 3 parentheses 6 equals 18. I'm just substituting that 6 in for a in the starting equation. 3 times 6 is 18. I get 18 equals 18. That is true. This must be a correct solution. Boom. We're rocking and rolling. Okay. We get here now. 2/5 x equals 10. So a little bit trickier. We need to be prepared for some things that have fractions in them as well. So a couple things I can do, right? I have 2/5 multiplying by x. So I can divide by a fraction. That's not my first suggestion. What I would do is I would get rid of this denominator here, this 5. Well, I'm dividing by 5, right? So what's the inverse of dividing by 5? That's multiplying by 5. So I need to multiply the right side by 5, and I need to multiply the left side by 5, right? So I notice 5 times 2/5, well, that's really 5 over 1, right? So 5 times 2 is 10. 10 divided by 5 is 2. It's going to leave us with this 2. Really, these 5s just cancel out, right? And now I'm left with 2x equals, well, what's 10 times 5? That's 50, right? Okay, x is not by itself yet. I don't have variable equals number yet. I have a coefficient of 2 in front of my variable. So to get rid of that 2, it's multiplying. I'm going to go ahead and divide, right? 2 divided by 2, 50 divided by 2, 2 divided by 2 is 1. 1x is left. 50 divided by 2 is 25. Okay, so I'm left with x equals 25. That's the look I'm looking for. So now to check it, right, I can plug 25 in for that x. So I have 2/5 times 25 equals 10. Calculator is probably going to be your best friend here. You might be very confident with fractions. Fifths are pretty friendly fractions. If you need to know, well, what is 2/5 of 25, right? 25 can be split up into fifths by 5. Well, 2 5s makes 10. 10 equals 10 is true. So x must equal 25. Okay. All right. Moving on to example C over here on the right. We have 2/9 x equals 1/3. Again, we have a situation where we have our coefficient in front of x is a fraction. I'm going to go ahead and treat it like the last one. In order to get rid of a denominator of 9, I can multiply by 9. So I'm multiplying this by 9. I'm going to multiply this by 9, right? We like to have fractions when we multiply. It's always just helpful. These 9s cancel out, right? Because 9 times 2 is 18. 18 divided by 9 is 2. So I'm left with 2x. And then over here on the right, I'm just multiplying across. 1 times 9 is 9. 3 times 1 is 1. Okay. And then some more simplification can be done with that fraction. 9 divided by 3 on the right is just 3. So I get 2x equals 3. In order to get rid of multiplying by 2, I do the inverse. I divided by 2. And I am left with something like x equals 3 over 2 or x equals 1.5, because if I did 3 divided by 2, I would get 1.5. Same thing goes for checking. For the sake of time, I'm not going to check every one. You get an idea. I would need to plug in 3/2 or 1.5 in for x up above and see if I'm left with the true statement. A couple more examples. You can follow along with me real quick. Nothing too crazy. We get a decimal. We get some variables on both sides again, and then we just get a basic one here on the left on A. So here, again, a habit that a lot of my students have made in the past, and some of them come with middle school with this. Some of them just pick it up from me. But I like to cut the problem in half at the equal sign because it shows me the left half and the right. And then whatever I do to one side, I do to the other. It's just a little bit easier to see. So I have 5x minus 2 equals 13. I need to get rid of this -2 hanging here. Well, to get rid of a -2, I can add 2. That means I got to do it on the right because -2 and +2, when I add them, give me 0. So they're gone, which is good. I'm trying to isolate this variable. 13 plus 2 is 15. Now I'm thinking 5 times what number is 15? Well, in order to do that and make it easier on myself, I can do the inverse of multiplying, which is dividing, and I'm left with x equals 3. Okay, moving on to this example over on the right. I set up above, when you have variables on both sides, like this 4x and this 6x, it's much better to move the smaller one, okay, because then you're not going to have to deal with, there's a lot better chance you're not dealing with negatives. So 4 is smaller than 6. That 4 is positive, so I'm going to subtract 4x to get rid of it because 4 minus 4 is 0, but that means I have to do it also on the right, minus 4x there. And I'm left with -1 equals, well, 6 minus 4 is 2x, and there's a 2 hanging on over there. So I need to get rid of this 2 now by subtracting. 2 minus 2 is 0. I'm left with 2x over here. And now I have -1 minus 2, which is -3. I get 2x equals -3. I'm going to divide by 2. I'm going to divide by 2. This is kind of looking like our last or example C up above. I get x equals -3/2, or I get x equals -1.5 if you did the division there. Same answer, just depends on if you want it in fraction or decimal form. It might be something we might ask you, hey, we want decimal form. We don't want fractions, or we do want fractions. Just some things to think about. This last example of the day is involving some decimals. So I'm left with this situation here on the right. I have 0.13x equals 0.17 times the quantity of 100 minus x equals 14. So I'm going to have to bust out my calculator here to do some of this math. First thing I'm going to do is 0.17 times 100. Okay, I'm doing this distributive property here, and that gives me 17, and they're both positive, so I'm going to keep it positive. And then I have this 0.17 times -x, right? So that's just going to be -0.17x. I have this 0.13x out in front. I need a positive sign here because I'm adding, equals 14. So do I have any like terms to combine? I do. I have x's here and here. Some are positive, some are negative. I'm going to take 0.13 and I'm going to add it to -0.17. And that looks like it's going to leave me with -0.04x. I have this constant of 17 right here that I'm going to leave. Constant of 17 equals 14 on the right. Okay, So now let's get rid of the 17 by subtracting. I get 0.04x. That's a negative equals, well, 14 minus 17. These are gone because 17 minus 17 is 0. 14 minus 17 is negative 3. And now I have to divide by this decimal here, divided by negative 0.04. That means I need to take the other side and divide by negative 0.04. I am busting out my calculator here. I have a negative divided by a negative, I know is a positive, and I have negative 3 divided by 0.04 gives me 75. So I get x equals 75. Again, that can be checked by going up above, plugging in 75 here, and plugging in 75 here. I would need to make sure I came out with a true statement for that to have been my correct solution. Wrapping up lesson 2, it says, now, just keep this in mind because this will be kind of our leeway into lesson 3. It says, now the above equations do not have any context to them. Okay, and what I mean by that, it says these are the most basic version of an equation. Oftentimes there will be context there. The next lesson, so lesson 3, will help us solve an actual problem that may be presented to us in real life, right? So being able to solve equations is fun. It's a great skill. It's going to take you far in math if you get confident and just get good with it. But right, there's a lot of times where we need context. We need a story with it, right? We're solving an actual issue or problem. These are just kind of at the most basic level. Here's an equation. Can you find the solution? Keep that in mind. Thanks for following along, and I will see you on lesson 3.